So the reason why I kind of want to guide you through this question is because this question has something that this has happened. This question happened. Let me give you a history of this question. This happened in 2012 when this bear question show up. And then there was like I should on a practice exam there's a teapot questions. I didn't choose to go over it on AP exam on 1 year on AP thing. I end up showing up the potato question, which is another main questions that show up on the things. So I hear that this question here is very, very important that you guys got to be able to do this. And also talk about second derivative. Um, Now, the second derivative, meanwhile, I'm going to talk about second derivative as well because um, if I were to use a tangent line approximation, and I want to adding additional thing on part B. Those are things that you have to pay attention to. So this question is really much related to like a potato question. It's a potato question has a temperature and the time. Student kind of got confused with variables and so I'm gonna give you the question today as a homework. So that's why I choose to go over this one. The rate at which a population of bear is national forest growth to proportional 600 minus b to the t, where t is the time in years, b of t is the number of bear. At the time 0, there are 200 bear in the forest. The rate of change of population bear is modeled by differential equation. dB dt is equal to 1 half 600 minus b, and y equal to b to t is a solution of differential equation with initial condition b to 0 equal to 200. It's a number formed faster at 300 bear or 400 bears. So first of all, we have to annotate everything. Now, the one thing I'll probably annotate something that's super important, which is definitely this one. This is a dB dt, and this just the rate. Okay, so this is the first one. And also initial condition, that's the second things I want to put very, very, very important. And of course, b to the t is a bear, um, and proportion. So proportional to 600 b to the t. Um, and this is also initial condition, just in different formats. That's going to be like this. Um, so for first part, that they want to know is growing faster at 300 bear and 400 bear. So when you look at this part, you have to pay attention to up here. Then I'm going to do is dB dt is equal to 1 half of 600 minus b. Lord, pay attention to here. Um, so dB, and then I'm going to plug in 1 half times 600 minus 300 versus dB dt is equal to 1 half times 600 minus 400. And then, of course, this one is going to be bigger because 1 half times 300 is going to be greater than compared to 1 half times 200. So that is the part that you have to say your reasoning. Your reasoning because your dB dt is greater at 300 bear. So 300, so you're going to say this is 300. And because dB dt is larger, right? dB dt is larger. Now I want to add additional part on part B. Now part B has a lot of interesting things. This part, like they will ask you in different format on the MCQ. I'm going to talk about this one. It's really important. So this part is something that we did talk about, but I want to stress out something though. They looking for d2b dt. So d2b dt and dt squared. So therefore, you have a dB dt, right? dB dt is equal to 1 half times 600 minus b, right? And then I'm going to take a derivative respect to time. Laura, don't worry about writing. Just worry about pay attention. So d 2b dt T2 because you already finished writing yesterday. So this part I can say that's equal to 1/2 times 300, 600. So it's going to be 300 minus half b, right? And then I can take a derivative of this. So to take a derivative of 300 is equal to 0. So 0 minus 1/2 dB dt. And that's equal to negative half. Now dB dt is what we have originally. So the rate is based on the original rate. The second derivative is based on the original rate. So therefore, I'm going to plug in this part is the 1/2 times 600 minus b, right? And then you went on to solve the problem. So that's equal to negative 1/4 times 600 minus b, which is b is going to be 450. And then that's the part I want to talk about. Negative 1/4 times 150. And it's concave down. Now, I'm going to lead to this question, talk about something else. If concave down, now, if I were to do a tangent line approximation at 450, not just say, hey, I want to do a tangent line approximation at 450, or somewhere near around 450, is that going to be over approximation or under approximation? If I use tangent line approximation and I'm trying to calculate the what happened, how fast they have like approximation, are they going to be over approximation or under approximation? So here is a part that is a little bit different than before. Here's a part is on MCQ. They're going to ask you, are they going to be over approximate or under approximate if you use tangent line approximation? Now you're going to be like, wait, what kind of clue is already given to me on this part? What kind of answer are we found? What do we find in part B? Second derivative and concave down, right? So if it's concave down, is your tangent line approximation going to be over or under? It's going to be over.
Why over?
That's a good question. Why over? If you have something concave down, and if you have a tangent line, the tangent line, you can draw it out. Make sure you understand this drawing. If you have a concave down, your tangent line approximation at near that point is always going to be above. Does that make sense? Now, if it's a concave up, what will happen? Your tangent line approximation is always what? Underestimate. Do you see that? And this is the one thing I wish to talk about very beginning of the year, but I didn't. And I want to go back to catch up because sometimes they ask this. So are they over approximation or under approximation on the tangent line? It's really based on your second derivative. If your second derivative is negative, which is concave down, your tangent line is always above. Remember we did a Karate Kid? That when you have this, like, right, the concave down, your tangent line is always above. So your tangent line is over approximation. And if it's concave down or concave up, then it's going to be like this. Your tangent line is always under approximation, at least somewhere near there. Always. It doesn't matter before or after, it's still going to be, doesn't matter before or after the point. It's always going to be the same. Longer somewhere is near. If something is very far away, it's not going to be able, because somewhere down later maybe concave up or concave down. We don't know. But we only find out that region is concave up, then your tangent line approximation is going to be under approximation. If it's concave down, your tangent line approximation is going to be over approximation. That makes sense? Everybody understand this?
So we're not expected, like, if we get that question, we're not expected to find the tangent line. We can just use like the second derivative and like.
Usually they will say sometimes they will say, hey, can you use an equation tangent line if I get this initial condition and at this particular point, and also it's possible for you to find the second derivative, and you say the second because the tangent line doesn't tell you are they over or under, but if you take another derivative, you can figure out are they concave up or concave down. If they figure out it's concave up, then it's always going to be under approximation. It's concave down, it's always going to be over because the way is the graph is setting.
Oh, so they'll probably already asked us to find the tangent line before or something.
Yeah, I cannot predict what they're gonna ask because it's not possible. But I will say they have a lot of those questions, especially on FRQ. They will ask that way. So, or at least they'll give you opportunity to find out the second derivative, and you can prove based on the second derivative. Because equation tangent line does not prove it unless you find the actual value, like the homework questions. We find out are they over or under. But the homework question is xy over 2, so it's hard to take a second derivative because it's mixed together, so you cannot take a derivative. Ethan? He's only now. Do you understand?
Yeah.
Okay, so if it's concave down, it's always over approximation. It's concave up, it's under approximation. Now let's talk about the last part here. Last first period they did this similar question and they got it wrong. So I want to talk about it again. Is this particular part, which is dB dt. So dB dt is equal to 1/2 of 600 minus b. Now, some people say, can I distribute this? No, you don't want to distribute this because you don't want to have a 300 connected to the b, half b. What you want to do is you're going to do separation variable and you're going to try to evaluate as much as you can. So what happened is in this question, you want to do dB. I'm going to always times dt on both sides. This is always my first step in order to prevent you doing anything dumb. And now divide the 600 minus b because that you can divide. Because if they're adding and subtracting, they cannot divide it over. You can only add and subtract over, but you have multiplied by dt, you really cannot move over. Does that make sense? The only way is to divide it over to the other side. Once you distribute, is actually make it problem worse. So you don't want to distribute. Does that make sense? Because you distribute to be connected. Connected, you cannot move. Okay, so now what we're gonna do is dB. dB is over 600 minus b equal to half dt. Now you did separate a variable, even though there is no t, but that's still a constant. Are we okay here? Now the problem is when they take integral on the first period, and I thought that, crap, I really didn't do a good job explaining that part. What is the integration of dB over 600 minus b? I know you know, I know you know. I need to ask somebody who doesn't know. Let's ask Sarah Chung. I don't think you know, but prove me wrong. Good. You proved me wrong. But the problem is that u equal to 600 minus b, du equal to negative dB, because that part is gonna be the one that it's gonna be Achilles heels where people screw up. At least that's yesterday. So therefore it's gonna be negative ln of 600 minus b is equal to half t plus c. Now this is the first part. The next part is multiply everything by negative, so it'll be ln of 600 minus b. Why? I need to isolate the b, so I need to get rid of negative sign. So negative half t plus c. C is not going to change because it's multiplied by negative 1. If e to the both sides, it's going to be 600 minus b equal to e to the negative half t plus c. So e to the both sides, e and ln cancel out. Maybe I should write it out to make a better video. Um, so I say e to the ln of 600 minus b is equal to e to the half t plus c. Now e and ln now cancel out. 600 minus b is equal to e to the negative half t plus c. Now this one is a to the m times a to the n equal to a to the m plus n. So this is only happen when you e to the both sides. You got e to the c. Therefore, it's going to be e to the c times e to the negative half t 600 minus b. Now, a lot of people says they don't understand that part. But e to the c essentially just means another constant named c. So therefore, it's equal to c e to the negative half t 600 minus b. Now, if I move both as simultaneously, I can solve for b is equal to 600 minus c e to the negative half t. I can plug in 0 here and 200. So 0, 200 is the coordinates. So figure out always a coordinate. So it'll be 200 equal to 600 minus c e to the 0. You'll find out that's 1. So c is equal to 400. So you can replace that. It's also equal to 600 minus 400 e to the half t. And then you got a final answer, and that's your final answer. That's your correct answer of all. Now, what do we learn here? We learn if it's something that over b, use substitution, use substitute it. Now, if it's the second power or half power or 3 half power, you cannot use natural log. A lot of people tend to use natural log when they see fraction. Not all the time. It's the bottom is to the first degree and top is the derivative to the bottom. That you can use natural log. If it's 2-degree difference, y minus 2 to the second, then can I use natural log? No, use substitution. So I want to stress that, make sure that you guys always on the right track. Hopefully I explained better the second time. Also additional explaining this diagram that you have to be able to draw inside your head. That way you can say determine. Now, if you draw it, does not mean justification. You can say is concave down, therefore it's over approximation. That is justification. Drawing, it does not mean justification on AP exam. Concave down is, however, how do you find a concave down? You might need to find the second derivative. They might give it to you. You never know. You cannot predict how the question is going to word it, but you can predict, you can know your knowledge for sure. Then it's always cover all background. So this question I re-stress again, that makes you understand a little bit better. Yes. I got C 400. Okay. Now we're gonna give you a question of FRQ. I don't know what time we get off here. Okay. So we're gonna give you an actual question. It's 15 minutes. So so we have this questions. Hold on, let me. Yeah, no. I'm gonna give you a question that is something like something along the line what an AP exam is like. This is an easier version of it. Ideally, I want you guys to get this type of question 9 out of 9. Now, are you gonna get 9 out of 9? I don't know. Ideally, I want you to get 9 out of 9. So I want you to make sure that look at these questions here. Can you guys see? So how much time I will spend on this question? For this easy one, probably 3 minutes, 5 minutes. But you have 15 minutes to do it. But I'll give you 7 minutes. Half.
How would you want us to do A exactly if we can't?
It's like estimate.
Well, we did earlier.
No, I know, but like if it's like already done.
It's like
Yeah, but they say it's portions of a sketch to curve through portion 01. We did that on one of the homework questions. Question 18.
You know, I know how to do it. I was just saying that like never mind.
Okay. And like I said, if you don't know how to do something, uh keep on going. Don't get stuck in one part because the first part's only worth 1 point. Second part's only worth 2 points. The last part is worth 6 points, so you cannot miss the last part. Try your best. If you spend a minute and you don't know what's going on, then just go to the next part. But you do have 15 minutes to do those questions. We get off at 9:12, right? 9:10. I'll give you 5 more minutes. Get 3 more minutes. Haven't finished? Okay, you finished? You finished? Oh, sorry, Katie. Yesterday, I wasn't like trying to ignore you. I was playing a chess game. I was like, no, I have to win this match, so I'm just gonna block it off. So it looks like I wasn't trying to answer your question. Yeah, I was winning, that's why. If I was losing, I'll be like, it's okay. I hate when it's winning and somebody come talk to me, and I hate especially when I'm winning. My wife's told me, it's like, go take the trash out. Like, damn it. You could have told me while I was losing. I would have resigned before anything. Yeah, of course. I was like, I'm winning for the first time. I lost one game against David, but I actually won one game against David too. Can I go over it now? So let's talk about the first point. The first point, Katie, this is the first point, which is 0. 0, 1 is right here. And just kind of follow the curve.
You know, I just didn't know how you wanted us to do that because, like, we didn't have it on paper.
That's okay. You just kind of sketch it. But if you have some time to sketch like this, you're good. Pretty much follow the curve. 1 point plus 1. How easy is that? Yes. Right? And then go to the second one. The second one is not much harder either. If you look at it, it's y minus y1 equal to m times x minus x1. And that's the estimation using tangent linearization or some approximate something. But when you get approximate something, just do y minus 1 equal to m times x minus 0. Now, what is m? M is equal to dy dx, right? And m is equal to dy dx. Dy dx is equal to 3 minus y times cosine of x. Now, in this case, you got a 0, comma 1. So it'd be 3 minus 1 times cosine of 0. What is cosine of 0? So it'd be 2 times 1. It's actually a pretty easy number. So it'd be y minus 1 equal to 2x. And x plus 1. You want to approximate 0.2, just do 0.2 in there. Then that's going to be 1.4. Did anybody get that?
Yeah.
It's 2 points here. So there was 2 points. There was 1 point there. So you total got 3 points right now. You almost get a 3 right now. Now we haven't get all the bread and butter. Hopefully, if you got this, you got dy dx is equal to 3 minus y times cosine of x. Now the first job is always multiply that dx on the other side. So it's dy equal to 3 minus y, and make sure you don't distribute, because when you distribute, you get into a different type of problem. So that becomes dx. When you take a derivative, you can distribute, because it's easier to after you distribute. But when you take an integral, just keep it the way it is, move the dx to the other side, and then you can see that you can change that to like this. Did you do this? Did you get down to here? Okay, so that's going to give you another point. So you got 4 out of 9. Now, integration of this, u equal to 3 minus y, du equal to negative dy. Now, you see that there's a 1 degree difference. It has to be natural log, and it's not to the second or to the half, to the third. It's just purely just minus dy here. So therefore, it's going to be integration of the u and negative du equal to integration cosine of x dx. So therefore, it's going to be negative natural log of u, which is 3 minus y, equal to sine of x plus c. Did you do that? Here, you're going to give you 2 more points because you integrate both sides correctly. Now, if you get rid of 3 minus y, equal to negative sine of x plus c, and then you do e to the both side, 3 minus y, equal to e to the negative sine x plus c. Now, if you got the c is in the front, ce of negative sine of x, that should give you another point here if you put in the front, because that's where everybody start making mistake. And then you're going to get y equal to 3 minus ce to the negative sine of x.